Hello, my name is Martin Zettersten, and today I'm going to present work together with my collaborators Choi, Kirkorian, and Jenny Saffran on how children actively sample information during word learning. One of the things that makes learning words hard for kids is that they'll often encounter learning situations in which they have limited or incomplete information about word meanings. I'm going to focus on two examples. For one, the input at any given learning moment is often ambiguous. For example, in this case, it's not obvious whether the word fox refers to the pointy-eared dog-like creature or the spiky mouse-like creature. Another challenge is that words follow skewed distributions in the environment, with some words heard far more frequently than others. That means that children might have fewer opportunities to hear rare words like axolotl. In this talk, I'm going to focus on how active learning, kids' ability to actively sample from their environment, may help them solve some of these challenges. Children are not just passively observing their environment, but themselves help structure their early word learning curriculum, so to speak. How might children's own information seeking, their motivations and preferences in terms of what they want to experience and learn about, support word learning, especially in the face of some of the challenges I just outlined? For example, in the first learning scenario I showed you, an effective strategy would be to isolate input for ambiguous items. So focus in on just what that pointy-eared creature is called. In the second scenario, an effective strategy might be to actively select items that are experienced less frequently. So focusing in on the axolotl, for example. The idea that children actively contribute to their early word learning input is not new. I particularly like this quote from Lois Bloom going back to word learning debates in the early 2000s. And she said, children do not just wait around for other people to construct the word learning scenario for them, not on your life. Instead, they create the word learning process themselves. The words they learn are words they want to learn, the words they need to learn. So if we grant that children are actively engaged in structuring their word learning experiences, well, just what types of word learning events do they construct? What types of words do they want to learn? What types of sampling preferences do children have during word learning? And, well, what sort of consequences do these sampling behaviors have for learning? These are the two questions that I'm going to focus on in my talk, and I'm going to share the results from two experiments that speak to these questions. In the first experiment, we're going to ask how children sample words in situations where the input is ambiguous, kind of like the fox and hedgehog example. Our main question is whether children will choose to hear words that help them reduce referential ambiguity. To answer this question, we had 56 3 to 8-year-olds play a short word learning game on a tablet while visiting a local children's museum. And that game had two parts. In the first part, what I'm calling the exposure phase, children saw two-word, two-object word learning trials. And what we manipulated was just how ambiguous the novel word referent mappings were based on the input. Afterwards, kids had a chance to select which novel objects they heard labeled again during a participant-controlled sampling phase. So the cover task of the game is that kids are going up into space with Space Study and helping her learn the names of new alien creatures she encounters. And in the exposure phase, kids saw two trial types in this game. On disambiguated trials, novel words are paired with known words such as dog and pig. So on these trials, kids should be able to disambiguate word meanings and figure out that Biffer must go with that new alien creature and Kita must go with the other one. These kinds of trials are often called mutual exclusivity trials in the word learning literature. For another set of items, word reference was ambiguous. Two novel creatures were paired together such that it stayed unclear across training whether, in this case, Cebu refers to the blue creature or to the yellow robot-like creature. Children then had the opportunity to select which item they wanted to learn about next in the sampling phase. And our key question was whether kids would prefer to select items that had stayed ambiguous during that previous exposure. So what did kids do? I'm going to show you the distribution of participants who selected an ambiguous item on 0, 1, or 2 of their sampling opportunities. And the way to think about this graph is that 1 is selecting items at chance. And the more the distribution is shifted rightward, the more children are showing a preference for selecting the ambiguous items. And what we find is that children, in fact, do show a tendency to focus on previously ambiguous items when they have a chance to control their word learning input. So they're making choices that should be helpful for learning, right? Focusing in on items that should help reduce uncertainty about word meanings. Next, I'm going to show you data from a second experiment that sets up learning situations analogous to the second learning scenario I introduced, where some words are heard more frequently than others. For this experiment, we're going to first focus on children's active sampling in an active condition. And then later, I'm going to introduce some other conditions in the experiment and how they help us answer questions about active sampling's effect on learning. But for now, our question is similarly about sampling, specifically whether kids will choose to hear words they've heard less frequently and are therefore more informative. In this experiment, children were again learning the name of these novel alien creatures, where the cover task is that they're learning the names for Teddy's friends. But here, labels for items were presented individually, so the input was never ambiguous. Instead, what we manipulated was how frequently children heard words for each of the novel creatures. There were 8 learning trials overall, and the frequency distribution was skewed such that it roughly followed a power law distribution, with some words heard much more frequently than others. After that exposure phase, children entered, again, a sampling phase in which they received additional training. We're going to focus on just the active condition for now. In this condition, children could choose which of the 2 creatures they would get to hear the word for again. They had an opportunity to select among all possible pairwise combinations of the 4 novel critters for 6 total sampling trials. And we tested 73 3 to 5-year-olds in this condition. Our main question here was whether children would tune their sampling to past experience. Specifically, would they select items that were heard less frequently and therefore more informative during the sampling phase? So to set up the results, remember that children were making a choice between 2 items that varied in past frequency. We're just going to refer to these 2 options as image 1 and image 2 creatively, all right? On the x-axis, I'm showing you the difference in informativeness between these 2 options, where following an information theoretic formalism, informativeness is defined as the negative log relative frequency of the word in past training. You can basically think of this as a frequency metric, though, where higher informativeness corresponds to lower frequency, kind of like the axolotl from earlier. So as you go further to the right along the x-axis, option 1 is more informative, less frequent. And as you go to the left, option 2 is more informative. Just to orient you to the scale, 2 here would mean that one of the options occurred 4 times more frequently than the other in past training. On the y-axis, I'm going to show you the probability of selecting image 1. So 0.5 here would mean that children equally prefer their 2 options. They show no preference between those 2 options. So what do we find? We find a strong relationship between children's sampling preference and the informativeness of their options. Note that if you heard the 2 options equally frequently, so 0 on the x-axis, children are right at 50%, right, in their choice probability. So they're indifferent between those 2 options. And then, as one of the options becomes more informative relative to the other, children become more likely to select that more informative item. So they're showing that axolotl preference that I set up earlier. All right, so far we've seen that children will sample information about words in a smart way, so to speak, right? A way that should help them handle ambiguous or less frequent input. The question that might be on your mind, though, is, okay, so what are the actual consequences of these sampling behaviors for learning then? Does this kind of active sampling behavior support learning? So to answer this question, we introduced passive conditions in the experiment I just showed you, where children become passive observers that could not control what they're going to learn about next. So the second question we asked in experiment 2 is whether and how active control might benefit word learning. The way this worked is that in addition to the active condition, children could also be assigned to a yoked passive condition in which they saw the same input just selected by a counterpart in the active condition. And they themselves did not control that input. And we introduced two yoked passive conditions of this kind. To help set up the passive conditions, let's consider two possible ways that active sampling could benefit learning. And I'll just stress here that these possibilities are not mutually exclusive. Here I'm going to be pulling on existing explanations that have found support in the active learning literature, broadly speaking. So one possibility is that active control per se benefits learning, maybe because it enhances memory encoding during the learning event or supports attention during that labeling event. A second possibility is that active sampling is helpful because it allows learners to select information that matches their current knowledge state or is informative given past learning, the words they need to hear, the words they need to learn about, in Lois Bloom's words. To test these two possibilities, we introduced two passive conditions in addition to the active condition we've already talked about. In the yoked passive condition, children had exactly the same exposure as their counterpart in the active condition. But in the yoked passive exposure mismatch condition, sorry, I know that's kind of a mouthful, but in this condition, children saw the same words as their active counterpart, but the frequency with which these words were presented during the exposure phase varied randomly relative to their active counterpart. So just to stress this, what children saw during the sampling phase was identical across the yoked participants. And what varied was whether they themselves selected that input and whether they previously had the same exposure as their active counterpart. To bring this back to the two possibilities I outlined, comparing the active condition to the yoked passive condition now gives us some purchase on whether active control per se benefits learning. And if active selection supports learning mainly by delivering input tuned to past experience, we should see the largest difference in performance between the active and the yoked passive exposure mismatch condition. So we tested 219 participants total, 73 in each of the passive conditions, in addition to the 73 from the active condition that we have already met. After the sampling phase, we tested children's word knowledge in a two alternative forced choice test phase. And one small note here is that we also yoked similarly aged participants together. So 3-year-olds were yoked with 3-year-olds, 4-year-olds with 4-year-olds, and so on. We didn't see much evidence for differences across ages though, so I won't be focusing on that here. So what did we find? First, we found that children's learning in the active condition was actually quite similar to performance in the yoked passive condition, suggesting that active control alone did not necessarily lead to a boost in performance. However, kids in the active condition did better than kids in the yoked passive exposure mismatch condition. So that tells us that kids' active selections were less useful to kids who did not share the same past training during the exposure phase. And we see an overall difference across all conditions here, suggesting that active sampling overall was in fact beneficial for learning. So to sum up, I've showed you evidence that children will actively sample new information about words in ways that should support early learning. We saw that children will sample words that disambiguate past word learning evidence. And we saw that children's active selections are tuned to past experience in a way that supports learning. So with that, I'd just like to end by thanking the Infant Learning Lab team, which is my PhD lab, for their support throughout these projects, our funding, the Madison Children's Museum, where we collected all of this data. I'm looking forward to your questions and any comments you have, and thanks for listening.